my amazing students. This is Mrs. A, and I love math. Today we're doing lesson 72 in your Saxon Orange Book. And this is a rather long lesson, so it's divided up into several parts. So 72A is factors that are sums. So we're going to be looking for factors of this type. Look at this one, a plus b x squared minus a plus b times x minus 6 times a plus b. Anytime we see something like that where we have a plus b, a plus b, a plus b, we're going to factor out the a plus b because it is a common factor. So we'll factor it to the front and then we'll write what's left. So if we divide this whole term by a plus b, we just get x squared. We divide this term by a plus b and we get minus x. We divide this whole term by a plus b and we get minus 6. And then we will factor and just leave this alone. So we're going to keep the a plus b. We're going to factor the x squared minus x minus 6 into an x and an x. Remember, this minus here means that I have a plus and a minus. And then 6 could be 3 times 2 or 6 times 1. We're looking for, since that's a minus, we're looking for a difference of 1. So 3 and 2 have a difference of 1. So I'm going to look for the 3 and the 2. We'll cross this one out. 3 and 2, but I want the middle term to be negative. So I'm going to make the 3 the negative. So negative 3, positive 2. 2x minus 3x gives me that negative x in the middle, and they multiply to give me negative 6, and we are done. Here is our answer. So really, once we took the a plus b out, everything else was something we had already seen before. Okay, here's another example, and notice that I have an x plus y, an x plus y, and an x plus y. Okay, so that's what they meant by sometimes factors are sums that are already sitting there staring at you. So we're going to pull out the x plus y, and then we're going to divide this whole term by x plus y and get x squared. Divide this whole term by x plus y and get 9x. Divide this whole term by x plus y and get plus 20. And then all we have to do is leave the x plus y there and factor this. Well, it's a trinomial. So we're going to put x, x. This is positive, and this is positive. That means that both of these will be positive. And then the 20 could be what? 20 times 1, 10 times 2, 5 times 4. We're looking for a sum of 9. So wouldn't I use 5 times 4? 5, 4, 5x plus 4x is 9x. 5 times 4 is 20, and we are done. Here is your factored polynomial. Okay, so this is the last one of these problems before we move on. So they made it look a little bit more complicated. This one, I just didn't have room to write anymore because there's so many letters and numbers. But if you look at it very closely, I have my x squared and then everything in front of it, m times x minus 1. So I look over here, and this one has an m times an x minus 1. And I look down here, and this one has an m times an x minus 1. So that's a common factor, isn't it? So we're going to write m times x minus 1 in front. I'm going to use a bracket here just to keep it a little bit more separated. This whole big term divided by this is just x squared. This whole big term divided by this is 7x. This whole big term divided by m times x minus 1 is just 10. Wow, it looks lots easier now, doesn't it? Okay, so we're just going to bring down our common factor, m times x minus 1. And then we're going to factor this trinomial, x times an x. Positive, positive means these are positive, positive, and it means this one is a sum. 10 and 1, 5 and 2. That's it. But we want a sum of 7, so we're going to use 5 and 2. 5x plus 2x is 7x. 5 times 2 is 10. And we are done with that little portion and ready to move to B. Okay, so now we're on 72B, where we're working on pyramids and cones. Now this is where they draw all kinds of pretty pictures in the book, and I cannot draw worth beans, so I'm going to show you these problems in the book. Okay, so here we have so many definitions that I thought it would be helpful if I just explained it to you in the book. Okay, so here we go. A pyramid is a geometric solid with one face a polygon called the base. So now here is a pyramid and here is a right pyramid. I like the right pyramid. It looks kind of like a teepee, doesn't it? Okay, so the base is the bottom of this thing that it's sitting on, and here the base is the bottom that it's sitting on. Okay, now the polygon that makes up the base is going to be how we name the pyramid. So here, this base has 1, 2, 3, 4, 5 sides. If you look down at the bottom figure, and so that would be a pentagonal pyramid. So we can know a little bit more about what kind of pyramid if we know that the base is going to name the pyramid. So here we have a pyramid and its base, and the other faces are called lateral faces. And notice that each one of the other faces is a triangle. Okay, lateral means around the sides. So that's what we're going to, that's a lateral face, and that's a lateral face, and that's a lateral face, and the one they're all sitting on is called the base. Okay, now the common vertex is what they all go up to. That right there is where all of the lateral faces touch that one point. So it's a common point to all of the lateral faces, and we call that special point the vertex of the pyramid. And the segment joining the vertex to the center of the base is called the axis. So if we were up at the vertex and we dropped a straight line down to the very center of the base, you see that little point there? All the way straight through, that's called the axis of the pyramid. And then the altitude of the pyramid is the perpendicular segment from the vertex to the base. So here we go, this right here, that little dotted line right there that goes straight through from the base up to the vertex is called the altitude of the pyramid. And another name for altitude might be height. The length of the altitude is the height of the pyramid. In the figure on the left below, we show a pyramid with the component parts labeled. Okay, so now here is a pyramid. This is not a right pyramid. You see how this pyramid right here, there's a right angle between the base and the altitude, so that the vertex is directly above the center of the pyramid. Over here, we have a slanted pyramid, and here's the vertex, but the base is way over here. It got knocked over, didn't it? It was kind of slanted. And so we have lateral edges. This is an edge, okay? And lateral means on the sides, remember? The axis goes through the center. There's the axis over here. This is a pyramid. This is a pyramid, but it's a right pyramid. And the altitude is from the vertex down to the base, and then the vertex down to the base. Okay, notice that they're going to take the shortest distance down to the base. They're not going to go this way to get the altitude. The altitude is going to be the shortest distance down to the base. So those are some very interesting terms that you need to learn about a pyramid. The pyramid on the right above is a special type of pyramid. It's called a right pyramid. A right pyramid is a pyramid whose axis, remember this is the axis, straight through the center, is at a right angle to the base. The base is here, lying flat on the table, and this right here is a right angle. Note that in a right pyramid, the axis is also the altitude. This straight distance down here is the altitude and the axis. But in a slanted pyramid like this, the altitude and the axis are two separate things. Now, notice that this one's kind of complicated. This I like. In this book, we will confine our discussion to pyramids to right pyramids. So we're only going to play with these in this book. We don't really have to mess with those in this book. Okay, so that makes it very nice. Okay, so here we're on the page, top of page 293. There is a certain type of right pyramid that mathematicians consider important. These right pyramids are called regular pyramids. A regular pyramid is a right pyramid whose base is a regular polygon, which means all the side lengths are of equal length and all of the angles are of equal measure. The lateral faces of a regular pyramid are identical isosceles triangles. The height of a lateral face is called the slant height of the regular pyramid. Slant height is defined only for regular pyramids. In a regular pyramid, the altitude and a slant height determine a right triangle. In the figure below, we show a regular pyramid with the component parts labeled. So this is the really important one that we're going to do a lot of study on, is this regular pyramid. So let's look at it. So here in the regular pyramid, what they're talking about, you see this altitude here. And here we have it coming straight across here, right angle, and we have this slant height here. So inside this regular pyramid, there are right triangles to every side here, okay? So this is still a lateral edge. This is called the slant height. The slant height is the height of each individual lateral triangle. So all of these are lateral sides here, okay, and each one right in the middle, you can see there's a right angle here, and it goes straight up through the center of the triangle. Now remember that each one of these triangles here are isosceles, and each one of the triangles all the way around are identical because each one of these bases is exactly the same length around, okay? So it's important to know the characteristics of a regular pyramid. The base has got all equal sides, and each one of these angles is also equal. Okay, so here we're going to learn more about regular pyramids. A pyramid is classified and named according to the shape of its base. Here we show 4 examples. My cat is playing with the dresser. Okay, so here we have a triangular base. So this is a regular triangular pyramid. Here we have a square base. So it is a regular square pyramid. Here we have a rectangular base. So that's a right rectangular pyramid. Okay, now it's not regular because the sides are not the same. It's rectangular, but it is right because the top is straight up over the center of the base. And then this is a regular pentagonal because there's 5 sides as a pentagon pyramid. Okay, so here it says the right pyramid on the left is a regular triangular pyramid because its base is an equilateral triangle. The second right pyramid is a regular square pyramid because its base is a square. The third right pyramid is a right rectangular pyramid because its base is a rectangle. It is not regular. The fourth right pyramid is a regular pentagonal pyramid because its base is a regular pentagon. A cone is like a pyramid except that its base is a closed curve instead of a polygon. The curved surface between the vertex and the base is called the lateral surface. Now, here we're going to look at pictures of the cone. Okay, so here we have a cone that is not a right cone. See how smushed over it is? It's a slanted cone. And here is a right cone. Notice what they're saying is in a pyramid we had edges, right? We had edges along the base. Remember, we had all of those pyramids right there. Pyramids have polygons, meaning sided figures. Okay, they're triangle, square, rectangle, pentagon, but cones have got a circular base. Okay, so here we have a circle on the base. And it goes up like an ice cream cone, maybe one of those sugar cones, or like what we used to have in school is a dunce cap or something like that. Okay, so basically you can make one of these with construction paper, can't you? All right, it's round at the bottom, and then it goes up to a point. So it is like a pyramid in that it goes up to one point and it still has a lateral surface. This is the lateral surface, but it doesn't really have an edge because it's round. Okay, our other ones, our polygons, had a lateral edge. Our pyramids had a lateral edge. But since the cone is a circle, it doesn't have a lateral edge. It just has a lateral surface around the sides. Still has an axis, and the axis is the altitude. Still has a vertex, and still has a base, but it's circular. This one's just not right. It's all smushed over, and its altitude is different from its axis. Okay? So the cone on the right above is a special type of cone. It's called a right cone. The right cone is a cone whose axis is right angles to the base. Okay, note that in a right cone, the axis is also the altitude. All right, so remember the altitude is the height of the cone. But over here on this smushed over cone, the one that's not right, the axis goes straight through the center, but the altitude is different. Okay, so those are the same type of terms we had with the pyramid. Okay, well, we're on 294 now, and we're going to actually get to where we can work some problems here shortly. We're almost done with the definitions and about ready to go to the problems. We have just a little bit more. A cone is classified and named according to the shape of its base. So this would be a circular cone, and since it's going straight up, it's a right circular cone. The right cone below is a right circular cone because its base is a circle. The distance from the vertex to any point of the circle that forms the base is called the slant height, just like on the pyramid, okay, of the right circular cone. Slant height is defined only for right circular cones. In this book, we will confine our discussion to right circular cones, which means we're not going to have to mess with the smushed over ones. We just play with the right circular cones, which makes it very easy. Now, the really cool thing about right pyramids and cones is we treat them exactly the same way. The volume of a pyramid can be easily computed given the area of the base and the height. We describe in the box below how to compute the volume of a pyramid. Since a cone is like a pyramid, the volume of the cone is computed in exactly the same way as the volume of a pyramid. So we have one rule for both of them. Volume of pyramids and cones, right here. The volume of a pyramid or a cone is equal to 1/3 the area of the base times the height. Okay, now remember, the volume of something like a rectangular solid that goes straight up is area of the base times the height. But now it's going to be the area of the base times the height times 1/3. And that's all we have to do extra for a pyramid or a cone, is take 1/3 of the area of the base times the height. And that's it. So let's look at the first one. It says find the volume of the right rectangular pyramid. Okay, so now when we're looking at it, it's got 9 inches, 7 inches, and then its altitude, which is the same as its height, is 8 inches. So if we're going to do what they tell us to do right here, we're going to find the area of the base, and the area of a rectangle, remember, is length times height. So we're going to take 9 times 7, which is 63. Since it's inches times inches, wouldn't that be inches squared? So 63 inches squared times 8 inches. Now, we're almost done. Now we have to take 1/3 of that. So wouldn't the answer be... Okay, so here I've shown you more of the buck. So here's the 9 times 7. 9 times 7 is 63 inches squared. So that's the area of the base, which they labeled area of the base. Since the altitude is 8 inches, then the volume is 1/3 area of the base times the height. 1/3 area of the base is 63 inches squared times 8 inches. Now, we could either multiply all this together and then take 1/3, or we could really get smart and say, hey, taking 1/3 of 63 is easy, because 6 divided by 3 is 2, and 3 divided by 3 is 1. So 63 times 1/3 is 21, and then 21 times 8 is going to be 168. Now, notice it's inches cubed. Inches squared times another inch is inches cubed. And that is the volume of this right pyramid. Right regular pyramid. No, it's not right regular, it's right rectangular. Okay, so let's look at this one down here. Now we have a cone. Okay, a right circular cone has a base of radius 6 feet. So here you can see on here that there's a radius of 6 feet on the circular base and a height of 8 feet. Find the volume of the right circular cone. Now remember, I have to remember that the area of the base, since it's a circle, what's the area of a circle? Do you remember? Do you? Isn't the area of a circle pi r squared? Okay, now I'm going to lift this. Remember what our picture looks like. There's our picture. Our height or altitude is 8 feet, and the radius of the base is 6 feet. Okay, so now here is our answer. The area of the base is pi r squared. The radius of the base was 6 feet. 6 feet squared is 36 square feet times pi. 36 square feet times pi is 36 pi feet squared. That's the area of the base. The altitude is 8 feet. So the volume is 1/3 area of the base times the height, or 1/3 36 pi feet squared times 8 feet. Again, instead of multiplying 36 pi times 8 first, I would multiply the 1/3 times the 36 first. Because 1/3 of 36 is 12, and 12 times 8 is 96 times pi feet cubed, because we had feet squared and now another foot. Now it's going to be feet cubed. And then we're going to substitute in for pi 3.14, which is a very good approximation. 96 times 3.14 is 301.44 feet cubed. All right, so now we're going to look just a little bit more. That was volume. Now we're going to look at surface area of pyramids. Okay, so let me get that close here. All right, so look at this. We remember that the lateral faces of a pyramid are the triangular faces between the vertex and the base. So this is a lateral face of the pyramid. Okay, we define the lateral surface area of a pyramid to be the sum of the areas of all of the lateral faces. So there's a lateral face on this side, one on this side, one on this side, one on this side. To find the surface area of a pyramid, we add the area of the base to the lateral surface area. So to find the total surface area, which is the surface area, I'm going to add 1, 2, 3, 4 triangles plus the square base together, and I will find the surface area, the total surface area. Okay, so here, look at example number 6. Find the surface area of this rectangular square pyramid. Dimensions are in centimeters. So here is our pyramid, and it's 6, 6, 6, 6 on the base. So that's a square. They show you the right angles. And then this altitude here, this slant height, is 5, so that we can figure out the area of these triangles on the side. Remember, because we're dealing with a regular figure, each one of these triangles is going to have the same area. So we really only have to figure out one of them and multiply by 4. Okay, so let's look here at their solution. So here it says, since the pyramid is a regular square pyramid, the base is a square and the lateral faces are identical isosceles triangles. The area of the base is simply the area of a square. Remember, square is side times side. So the area of the base is 6 centimeters times 6 centimeters, or 36 centimeters squared. The lateral surface area is 4 times the area of one lateral face. So here they've drawn a picture of one lateral face. So they just basically pulled off one of those triangles on the side and they blew it up for you. And remember, the area of a triangle is down here, 1/2 base times height is the area of a triangle. And so the base is 6 centimeters. The height is 5 centimeters. So they have 1/2 6 centimeters times 5 centimeters. And that's going to be 15 centimeters squared. But then we're going to have to take that times 4. 15 times 4 is 60 centimeters squared. And then we have to add the base, which was 36. So altogether, it's going to be 96 centimeters squared is the total surface area of that pyramid. Isn't that cool? Okay, so that is the surface area of pyramids. And I have to stop because I have to turn the page. All right, so this is a pretty long section, but we're almost to the end of it. Okay, the last little part is the surface area of cones. So we just did the surface area of pyramids, and now we're going to do the surface area of cones. We remember that the lateral surface of a cone is the curved surface between the vertex and the base. So all of this right here is the lateral surface area. We define the lateral surface area of a cone to be the area of the lateral surface. Unfortunately, there's no simple way of computing the lateral surface area of a cone unless it is a right circular cone. The lateral surface area of a right circular cone is the product of pi, or pi times the radius of the circle and the slant height, or pi RL. Now, just right at this point in time, you're going to memorize that formula. Later on, you'll understand that a little bit better, but pi RL, pi times the radius times the slant height. That will give you the lateral surface area. To find the whole surface area, the total surface area, we add the area of the base to the lateral surface area. So the lateral surface area is pi RL. Just memorize it. L is the slant height, R is the radius, H is the height there, okay? And pi is just a constant, and we're going to use 3.14. So here is our example here, and then we'll be ready to work our problems. Okay, so we have a right circular cone that has a base with a radius of 8 meters and a slant height, there's the slant height, of 10 meters. Find the surface area. So first we're going to find the surface area. And then if we had, so the surface area is the lateral plus the base, okay? So if they were just telling us to find the lateral surface area, then we would only do this part around the side. The lateral surface area is going to be pi RL, which is a little bit above my camera right there. But to find the total surface area, we're going to add the pi RL to the area of the base, which is a circle, okay? So here is the whole formula put together. The area of the base plus the lateral surface area. The lateral surface area is pi RL, and the area of the base is the area of a circle, which is pi R squared. So the surface area is all of this put together. So we're going to have pi times the radius squared, which is 8 meters times 8 meters, or 8 meters squared, plus pi times the radius, which is 8 meters again, times the lateral surface area, which is 10 meters right there. Okay, so now we're going to do all of this math. So we're going to have pi times 8 is 64 square meters. Okay, so 64 pi. They didn't do the little intermediate step, but it would be 64 pi meters squared. And then over here we've got a pi and 80 meters squared. So 80 plus 64 is 144 pi. So let me show you that work there just so that you're not confused. So I'm going to work this problem for you. And here is our total surface area formula from your book. So I'll just put SA for surface area. So this part comes from the area of a circle, which is the base. And this part is the lateral surface area. So now pi, put that in at the end. R squared is going to be 8 meters times 8 meters, or 8 meters squared, plus pi R, which is 8 meters, times L, which is 10 meters. Okay, so now let's do the math. So pi 64 meters squared plus pi 8 times 10 is 80 meters squared, because we have meters times meters. So now we have a pi that we can pull out to the front. And then we just have 64 meters squared plus 80 meters squared. We add those two together and we get 144 meters squared times pi. Okay, so that's where they got that. Pi times 144 meters squared. Okay, so now they're right here. That's where I took you to. And then they're just putting in the 3.14 in place of the pi, and they're multiplying that out to get the final answer. And now we'll will do some practice problems. Right, so I think I was able to get 2 on my board at one time. We'll see if I can work them. Okay, so we have an A plus B and an A plus B and an A plus B. We have an A plus B as a common factor. So when I pull out the A plus B, then I'm going to have a whole big parenthesis that's going to contain a trinomial. So I look at this first term, I pull out my A plus B, and I have an x squared left. I look at the second term, I pull out this A plus B, and I have an 8x left. I look at my third term, and I pull out the A plus B, and I have a 15 left. So now, all I have to do is write this down, A plus B, and factor the remaining trinomial. This one's pretty easy because 15 does not have very many ways it can factor. So we have x times x. Positive, positive means that this is positive and this is positive, and this 8 is a sum of these factors. Well, let's try 5 and 3 because 5 plus 3 is 8, and we are done. And there is our answer. Hopefully you got that one right. Okay, so now we're going to try the next one, which is a little bit harder because now there's an extra C in there that we're going to have to pull out also. So copy it down and try to do this one on your own because these are your practices. Okay, so here we go. Hopefully you've done it. So I have a C and an M minus B, a C and an M minus B, a C and an M minus B. They're all in common, aren't they? So we're going to put C, comma, M minus B. All right, now you can use a parenthesis. I'm just going to move to a bracket because that is going to just keep it a little bit more separated here. This one and this one are going to go out to the front, and I have just the x squared. And then there's a C and an M minus B, so a minus 2x is all that's left. And a C and an M minus B, so a minus 24 is all that's left. So C, M minus B gets copied down, and we factor this big trinomial. X, negative sign means that this is a difference and I have two opposite signs. So I'm going to have one that's a plus and one that's a minus. I write down all my factors of 24, looking for two factors whose difference is 2. And I know the factors of 24 whose difference in 2, and that is 6 and 4. 6 times 4 is 24, but I want it to be negative, so I want the 6 to be negative and the 4 to be positive. Now let's check it. If I FOIL this part back together, do I get this part here? 4x minus 6x is a negative 2x, and a 4 times a negative 6 is a negative 24. So this big whopper right here is my final answer. Okay, I'm going to show you in the book because the book is much cleaner and neater than my drawing. But we have a rectangular pyramid, and the base is 10 centimeters times 8 centimeters, and the altitude, which goes up straight through the middle, is 7 centimeters, which is the height of the pyramid. Here's my drawing, and you can see why I showed you the book one. But what we really need is 10 centimeters times 8 centimeters is the rectangular base, and we need the height. So remember that a pyramid has a formula. 1/3 times the area of the base times the height. Okay, now the height is the same as the altitude. So the area of the base, since this rectangle here doesn't really look like a rectangle, but it's supposed to be, is 8 times 10. So 8 times 10 is 80 centimeters squared. And then the height is 12 centimeters and 1/3 of that. So 1/3 of all of that. Now, we can multiply these together and then take 1/3, or we can take 1/3 of 12, which is 4, and then multiply that by 80. That's the way I'm going to do it because it's easier. So 1/3 of 12 is 4. So 4 times 80 is going to be 320 centimeters cubed. And that is the volume of that figure, drawn better in the book than on my board. Okay, so this is our last problem, and you can see that very nice cone there at the bottom has an altitude, has a slant height of 15 inches. Remember, the slant height is along this edge here, and we need that slant height. That's the L in our formula. And then it has a radius of 9 meters. Here is my picture of the drawing. We have 15 is the slant height, 9 is the radius. So we're going to go with this formula. Pi, radius is 9 meters squared, gives us our pi r squared, plus pi, radius is 9 meters, and slant height is 15 meters. So now let's do the math. We have 9 meters squared, so that's going to be 81 meters squared times pi plus pi times, we have 9 times 15 meters squared. Okay, so 15 times 9, 9 times 5 is 45. 9 plus 4 is 13. So 135 meters squared. And then we can pull the pi out to the front. And then we're going to have 81 plus 135. 81 plus 135 meters squared. So 81, that's going to be a 6 and an 11 and a 2 and a pi m squared, which is meters squared. So now we have to do that last little step. We need to multiply 216 times 3.14 to get the final. So 216 times 3.14 is going to be 6 times 4 is 24. 4, 5, 6, 8. And then the next one, oh, it's just by 1, so it's 216. The next one, 6 times 3 is 18. 3, 4, 6. Now I add them all up together, and I'm going to get a 4 and a 12, and an 8, 9, 10, 18, 4, 5, 6, 7, and a 6 on the front. Let's see if I can write that down. Now, I had 1, 2 decimals. So 678.24 meters squared. 678.24 meters squared is the answer. I don't know if you can see that. I wrote really tiny, 678.24 meters squared. We are done with lesson 72. It was a really long one. So now go do your homework. This is Mrs. A, and may God bless your day. I just wanted to write that last answer down for you a little bit better. 678.24 meters squared. And there you have it.